What we can see from interstellar space is literally limitless. Black holes, bizarre stars, pulsars and quasars, you name it. And in the rich history of space explorations, there is only one mission that touched the mysterious interstellar space. Yes, you are right, the Voyager missions. Scientists are really dying to have the opportunity to open Voyager's cameras right now. What we can see will literally be a space exploration goldmine. But what if we had that luxurious opportunity? What if we could have a peek through Voyager's camera at this very moment? Join us on a journey billions of miles away to reveal how extreme interstellar space really is. I think we're all going to agree that the Voyager missions were legendary. It holds many firsts in terms of spacecraft exploration. Its technology was way ahead of its time. To be able to survive for almost 4 decades? That's truly incredible. And it was built in the 1970s. Voyager 1 is one of 2 spacecraft launched by NASA on September 5, 1977. Voyager 1's initial primary mission? To study the outer planets, including Jupiter and Saturn. But little did the scientists know back then that Voyager would go on more missions than what was intended, to travel beyond the solar system into the dark, cold, interstellar space. But before it crossed the boundary of the solar system, it left scientists with historical observations and photos of the solar system that we had never seen before. During its primary mission, Voyager 1 flew by Jupiter in 1979, taking detailed images of the gas giant and its moons. It also surprisingly discovered a ring around Jupiter, which scientists called the Halo Ring. Voyager 1 then flew by Saturn in 1980, taking even more detailed images of the planet, its rings, and its many moons. The spacecraft also discovered 4 new moons of Saturn, which were named Atlas, Prometheus, Pandora, and Janus. After completing its primary mission, Voyager 1 was redirected to explore the outermost regions of our solar system. In 2012, Voyager 1 became the first spacecraft to enter interstellar space, the region beyond the heliosphere, which is the bubble of charged particles and magnetic fields created by the sun. The spacecraft is still operational and is continuing to send back data about interstellar medium and the boundary between our solar system and interstellar space. But the Voyager that we know today is not the same as it was in the early stages of its life. Now, Voyager's cameras are turned off, and some of its parts are not working anymore. In 1990, the spacecraft captured its last ever photo. Voyager pointed its camera back towards the sun and took a series of images, including the famous pale blue dot. This is the last image that Voyager has ever sent to humans. A picture of 5 billion humans on a tiny blue sphere, the pale blue dot. Just take a look at that picture. Take a moment and fully grasp that that tiny blue sphere right there is us. The Voyager captured billions of intelligent human beings being gently cared for by its home planet. The Voyager captured Earth in a tiny speck of light, just a minuscule 0.12 pixels in size. The Voyager captured this image 3.7 billion miles or 6 billion kilometers away from our planet. But just 34 seconds later, the camera on Voyager 1 completely shut down and was never turned on again. Why did our scientists decide to turn off the camera? And how did Voyager's cameras really work? Voyager 1 is equipped with 2 different cameras, a wide-angle camera and a narrow-angle camera. Both of these cameras were designed to capture images of the planets and moons during Voyager 1's mission to study the outer planets of our solar system. The wide-angle camera has a 3-degree field of view and is capable of capturing images of large objects like planets and their rings. It uses a 2.3-inch or 58mm focal length lens and a 0.5-inch or 12mm aperture, which allows it to capture wide-field images with a relatively short exposure time. The narrow-angle camera, on the other hand, has a much higher resolution and is designed to capture detailed images of smaller objects, like moons and asteroids. It has a 0.12-degree field of view and uses a 31-inch or 800mm focal length lens and a 0.14-inch or 3.5mm aperture to achieve its high resolution. Both cameras use a Vidicon tube as their image sensor. This is a type of vacuum tube that converts light into an electrical signal that can be recorded or transmitted. A Vidicon tube is covered with a thin layer of photoconductive material that reacts to light by changing its electrical resistance. As light strikes the photoconductive layer, the electrical signal produced by the tube varies, creating an image. To control the cameras, scientists on Earth sent commands to Voyager 1 to adjust its pointing and exposure time. The spacecraft then uses its onboard computers to execute these commands and capture images of its targets. But how did the Voyager send these images back to Earth? Every image that the Voyager has captured takes around 5 million bits of information, or just half a megabyte. For you, this might not sound like a lot, but when you're sending it from billions of kilometers away, it was extremely difficult. Back when the Voyager still had fresh legs, it could send up to 115,000 bits per second because it was way closer than it is now. Today, the spacecraft can only send 160 bits per second. Doing the math, this would take the spacecraft 8 years to send just a single image. Due to the camera's ability to capture images at a faster rate than it can transmit the data, the Vidicon camera's signal is saved onto magnetic tape. As time passes, this data accumulates and can be sent whenever Voyager 1 has a strong communication connection. But you might be wondering why the camera on Voyager has not been turned on for the past 30 years, and what would happen if we did that right now. The Voyager exceeded anyone's expectations when it traveled well beyond the solar system, and our scientists were eager to push Voyager to its limits. In order to do that, they needed to limit anything that uses the energy of Voyager, including its cameras. By turning off Voyager's cameras, the spacecraft could freely investigate the interstellar medium, which was the new primary goal for the spacecraft. Scientists wanted Voyager to prioritize the instruments that would detect interstellar plasma. Now that the Voyager is in deep interstellar space, what would happen if we managed to turn on Voyager's camera once again? What can we see from its location right now? It is crucial to note that Voyager 1 is situated at a considerable distance from the Sun, about 13.9 billion miles, 22.3 billion kilometers away, which would typically mean that the spacecraft would be enveloped in total darkness, right? But this is where the misconceptions begin, because the Sun's light can still very much be seen by Voyager, and it is 16 times brighter than the moonlight on Earth, illustrating the immense power of the Sun. Even if the Voyager is billions of miles away, the Sun still provides sunlight to the Voyager, and, well, it's the largest space object that the Voyager can see. In fact, if we were to switch on Voyager's camera right now, we wouldn't see anything remarkable or significant in the vicinity because the cameras on Voyager were primarily designed for planetary exploration. The image that the Voyager would take would appear grainy and pitch black, with only small pixels of the Sun and some planets barely visible. But let me tell you something interesting. Even if Voyager 1 is almost 15 billion miles away from Earth, if it would take a photo, the constellations would look exactly the same as they do here on Earth. If it wants to see another perspective of our galaxy, it would need to travel thousands of light years just to see a shift in the stars. When will the Voyager accomplish this? This will take millions of years, and both you and I will be long gone. That is how vast our universe is.